Good day everyone, I'm Huang Kai from Section 5. Today I'll be explaining three assembling language programs from our lab assignment Q1, Q3, and Q5. Let's go through each program in details. So in Q1, we're working with two variables. Variable 1, which is initialized to the value 1. Variable 2, which is initialized to 9. So first step, we move variable 1 into AX. At this point, AX holds the value 001H or decimal 1. It's like the program output here. So the next, the line 2, we move the value of variable 2 into BX register. Now BX contains 0009H. Then is the exchange. We exchange the values between AX and BX. After this, the AX holds 9 and BX holds 1. And step 4, we store the new value of AX, which is 9, back into variable 1. So variable 1 is update 1 to 9. And the last point, we store the value of bx, which is 1, back into variable 2. So variable 2 is update from 9 to 1. Then we move to Q3. In Q3, we perform a combination of arithmetic operation on three variables. And variable 1 is 5, variable 2 is 10, and variable 3 is 20. But variable 4 is unknown. So that's three variables. First step, we move variable 1 into EX register. EAX register. EX now holds 5, 00005H. Then the second step is multiply the variable 2. We multiply EAX by variable 2 since multiply use the implicit source EAX. The operation is EX multiply variable 2. So that's 5 multiplied by 10 is 50. So EX now holds 50, which is 32H, the decimal 50. And step 3, we add variable 3, which is 20 to EAX. Now EAX becomes 50 plus 20 equals 70. In hexadecimal is 46H. And the fourth step, we decrement EX by 1. So the final value in the EAX is 69. In hex is 45H. And here is the program running output. Then we move to Q5. Finally, let's look at Q5, where we perform an enzyme multiplication using multiply instruction. This program shows how multiplication of two 16-bit numbers produce a 32-bit result stored across DX and AX. Here are the steps. So the first step, move DX 0. We clear the DX register. This is important because multiply stores the upper part of the result in DX, and we want to avoid leftover data from previous operations. Second part, we load AX with 1000H, which is 4096 in decimal. Then we load this CX with 25H or 37 decimal. and the fourth part we multiply AX by CX, storing the result in DXAX. So that's 4096 multiply 37 equals 50,000. No, it's 151 thousand and fifty 552 decimal. So since this is larger than 16 bits, the result is stored in DXAX, and X contains the lower 16 bit of the result, and DX contains the upper 16 bits. So in hexadecimal, is 25,000 H. So here's the code, and the output is running out here. And that's all. That's my part of for this lab. So thank you for watching.